and we just start. All right. So I'll answer that question eventually in today's class. Don't worry. Uh, so we are going to discuss more about these layers and functions. Right. First, we talk about layers. There are three broad functional categories of layers. Totally, how many layers you see out there? 7. Out of it, there are three broad categories, it seems. What are those three broad categories? One category is called as generation of information. Second one is called as processing. Third one is called as delivery. Now, what are those? What are those layers? And what is that categorization? Where is it? I'll show you that. The application which generates the information with the help on its own or with the help of the human being is normally considered as generation of application part. The generation of information is the one that is done by your application. Applications are typically the ones which generate the information always, either themselves or with the help of human being. That means, for example, you have a browser. In the browser, there can be some web page information, but sometimes you also give some inputs, right? Like your username, password kind of stuff. That is human inputted information. Okay, so sometimes it can be like a mixture as well. Half human inputted information, half information generated by the application itself. It is like that. But ultimately, the only layer which is responsible for generating the information which need to be exchanged between the nodes is who? Is your application. So that comes into that category, generation of information category. These three layers are considered as processing layers. What is the meaning of processing layers? What do? They will process the data that is generated by application in various ways. They will process it. What is the meaning of processing it? Farmers grow, in the field, what do they grow? Some food item, right? But you won't be eating that as it is, whatever the same shape and format it is been grown in. So you won't. What happens in the middle? A lot of processing takes place, right? A lot of food processing takes place, isn't it? Even the items that you buy from the supermarket are processed, right? Now, these three layers are processing the data according to the need of the transport. We have to process it and make it ready to transport it from one place to other place. Okay, we have to process it and make it ready. We can't send it as it is in the same format that the application is generated it. Why we can't send it? Lot of troubles are there with that. For example, application has generated a 2 GB file. It's a big movie file. Application is sending. All right. So what happens in that case? If application has generated a 2 GB movie file, can we send a 2 GB movie file in one shot? Can we do it? We cannot. Why we have to do? What we have to do? We have to divide that into small pieces and we can send piece by piece. Who does that piecing? Who does that division of the data? Who cut that into pieces? One of these three layers, one of these processing layers. Who is that? Which processing layer will do that job? Transport layer will do that job. Cut it into pieces. Okay, into thousands and thousands of pieces. You see, now you are understanding what is the meaning of processing. For example, whatever the data we are sending is very important information like mail. Okay, what need to be done to the mail? The mail information must be encrypted. should be encrypted. What is the meaning of encryption? The mail information is in English language. It should be converted into some secret format. You see? Otherwise, what happens? If somebody in the middle captures that information, if they easily convert it into English language by using the ASCII language, okay, ASCII coding, ASCII decoding, then everybody will be able to read your letter that you are writing to your friend. We don't want anybody to read our information. What we wanted to do, we wanted to encrypt that. You see, we wanted to encrypt the data. So what we are doing, application has done his job of generating the information, but presentation layer is converting it into a secret format. Processing or not, what is presentation layer doing? He is not generating any data. What is he doing? He is processing the data that is generated by application. In what way it is processing? It's converting it into some encrypted format. Are you understanding that? Okay, so all these layers will do the processing of the application data in various ways. Every layer has got its own duties. Of course, we have to study each layer, what do they do and what their functionalities are. We actually go and study that part. But I hope as a broader category, you are understanding about what is the meaning of processing of the data, making it ready for sending. Are you getting it? Okay. So this guy generates, these guys will process one after the other. This guy will do some processing. This guy will do some other processing. This guy will do some other processing. You see? I will first put a general example, then after that, you eat rice. You can eat rice. But when actually it is being grown in field, should be processed, right? There are various stages of processing. It will go to mill first, polishing machine. Then, when they have to sell it to a premium price, they will do white coater on that. They will put some kind of color on that. You see? All these what? This is like processing. Various levels of processing. It's not one processing. Various levels of processing. Will take. Finally, you will buy it, and get it to your home and you cook that and then you eat it. You see? Now, if this data to be delivered, it should be first processed. You're asking the question. You're asking the question. What is the processing? Session. Okay. Session will include some kind of important information related to this, the data that is being forwarded. He will add some additional details like what? For example, if this application generated the data, if it is sent to presentation, he will encrypt it. But when it is sent to session, sometimes session can add some timer related values, like at what time this data is generated. Such kind of information will be added by your session. Okay, some important details about the data it will add, but detailedly we study later what exactly each layer will do. I don't want to explain all the things at this stage. I wanted to only explain about this group called as processing. So make the data, take the data from application, the generation of information guy, process it and make it ready for delivery. Now, these below layers are called as delivery. What is that now means? Data is originated, data has been processed, now ready for what? Delivery. These three layers are going to take it up and deliver it to the destination. Okay, so the responsibility of these three layers is to send the data from what? One place to another place. They have to deliver it. Three layers we have to deliver, not one layer. It's three layers we have for delivery. Okay, so if we have one machine here in Hyderabad, we have one machine in US. Right now we are using GoToMeeting as the application. Right now GoToMeeting application is generating data or not? Yes. How? My computer screen, it is capturing and sending it to online guys. My human voice, my voice, My voice is also captured by the computer, that is converted into digital data, and my voice also is going to the GoToMeeting server. Now GoToMeeting server is placed in US. Okay. Now my computer screen and my computer, whatever the voice I am generating, is generated by which application? Is completely generated by which application? GoToMeeting application. Now GoToMeeting application generated data will be processed. Will be processed by how many layers? Presentation, session, and transport. After that, what happens? After that, the data will be beautifully packaged, okay, and delivered to where? First, it will be delivered to GoToMeeting server. From GoToMeeting server, it will be delivered to all the online guys who are listening to this class. It will be delivered to their machines. You see? So it should be delivered. How many layers are delivery layers? 3. You understood the broad classification now for the layers? Generation of information, processing, delivery. Now we have to start worrying about one broader category. Which category we take up first? Okay, individually also we have to study each layer. First we have to worry about one broad category. Which broad category we are going to take? We now today going to understand about delivery layers. Okay. Why do we need 3 layers for delivery? Network, data link, and physical. Now you see, delivery layers are 3. If you give the processed data to the higher level delivery layer network, with the help of its lower level delivery layers, data link and physical, the data will be delivered to the destination. On the destination side, if the data is received by the physical, it will be forwarded to data link layer here, then it will be forwarded to network layer. He will forward it for processing to the higher layers. Actually, processing is here above. The processing layers are there. So processed data will be given to delivery. If the received data will be sent to processing. It's simple. On the sending side, what happens? There is data that is already processed. What need to be done with it? Delivered to the destination. On the receiving side, what should happen? Reverse. Once the data is received, delivery layers will give the data to processing layers, because processing layers have to do the reverse activity. Okay. For example, sending processing layers have divided the data into 10 pieces. What the receiving processing layers need to do? They have to combine those 10 pieces. But who receives those 10 pieces? Delivery layers. Delivery layers, one after the other, they will receive it. They will have to send it to the processing layers. So that processing layer will combine it. Combine those 10 pieces together. Okay. Now we are not learning anything about processing layers. Today we are concentrating on what? We are only concentrating on delivery layers by assuming that already there is some processed data. Assume that, let us explore the layer strategy that is there with the 3 layers by assuming that some X bytes of processed data is ready to be delivered from one place to other place. Okay. First thing we need to understand is why the hell we need 3 layers for delivery. Are you understanding it? Why do we need 3 layers for delivery? Okay, that's what is the first thing we need to understand. So for the next 10-15 minutes, we are going to spend time on that, in understanding why do we need these many layers, in for what purpose. Ready? Assume that we have only one layer for delivery, which is your physical layer. All imaginations, guys. We are imagining that for delivery, one layer will be enough. Physical layer is enough. So Data that is processed by the processing layers is given to which layer? Only one delivery layer called as physical layer. We want our physical layer guy to be delivering it to the destination. Only one layer is there. What are the troubles? What are the problems we face? We see. Normally, typically, physical layer could not attach any header. It cannot attach any kind of header, physical layer. How many layers typically will be able to attach the headers? Above 6 layers can attach the headers, their own kind of information. Physical layer cannot attach any information at all. If you take only one layer, what happens? This guy is generating the information. Assume that guy is generating the topmost left corner guy is generating the information. If the data is given to the physical layer will pump it like this, and it will be sent to every machine there connected to that, connected to that joint. Whatever the machines are connected, it will go everywhere. This also goes here to this joint. From there it will reach every joint that is out there. You see, like that it will be reaching every joint there ultimately. And from every joint, information will spread what? To every other joint. There is no restriction here, because who is taking the responsibility of delivery? Physical layer. You see, only one layer we have. That guy cannot do the any kind of restriction. Why there is no restriction with physical layer? I will explain you. Physical layer are what, guys? Electrical cables. If you send electricity into one wire, that wire is connected to some tens of wires. What will happen? If you send electricity into one wire, what happens, guys? Electricity will go into every wire that is connected, right? Common sense. If you don't believe that, you can try with one experiment. You connect to electricity on one wire and one of the joint you catch. What happens now? You definitely get the shock. You see, basically at physical level, what will be transmitted? Electrical pulses. Okay, yesterday I talked about it. Electrical pulses will go. It goes everywhere. There is no restriction. Moreover, if you have only one layer, because it is not attaching any header, no addresses are there, no addresses are attached, the receiving computers will be confused. All the receiving computers. Hey, we have received the data, that is okay because we are in this mesh. We have received the data, but is the data is for us or not? Is the data really ours or not? How do we know whether it is for me or not for me? Everybody received the data. There is no restriction applied. It gone everywhere. That means physical layer, only using one layer is never a solution. Okay, why? Two big issues. If you imagine this is a worldwide network, the traffic will, which if it is generated from one computer, it will go to every computer in the world, which is nonsense, first case. Second, the receiving computers will never know whether the data is for them or not, because there is no address kind of information attached at all. You see? So one layer delivery will never work out. That means delivery at least must be how many layers? 2 layers. Okay, what is the second layer going to do? Layer 2 going to do? We assume that layer 2 going to implement some kind of addressing mechanism. It will attach some addresses in the part of header. Which layer? Layer 2. Now the data is processed. Now you are imagining in the air, guys, data is processed by the processing layers given to delivery subunit. In the delivery subunit, how many layers are there? Not 3, 2 layers we are imagining right now. We have to see all the situations. What happens if we have 2 layers? Okay, good. The layer 2 in your computer will attach two address, one from address. It will attach 2 addresses. That means every computer in the world is associated with a address. What is it? Every computer in the world is associated with a address. You have to attach a to address and from address in your for your process data. Assume that your process data is 20 bytes that has come from the higher layer. Your delivery layer right now is going to attach two addresses. Assume that each address is some 8 bits, 1 byte. So to address is 1 byte, from address is 1 byte. You're imagining it? So total it is going to become what? If you receive some 20 bytes from higher layer, you are attaching two additional bytes. One is to address, one is from address. Totally your data is becoming how much? Processed data is 20 bytes. For that we are attaching two addresses. Each address is 1 byte. How much it is becoming totally? 22 bytes. Now yesterday somebody did not understand what is the meaning of header. Now it is the time for you to understand what is the meaning of header. Now our delivery layer, one of the delivery layer is attaching these address information, right? One is to address and one is from address. Those two things are called as header fields. That is your header that is attached in that particular layer. You see? Understanding the header concept now? Though any additional information that is attached at any layer is called as a header. Right now these address details are header for us. If you write a letter, inside the letter content will be there. Outside the letter to address and from address will be there. The to address and from address is header for us. Attached by which layer in this case? Delivery layer, layer 2. Okay. Now what happens? Now a beautiful thing happens. You see, this guy attached the header addresses. 20 bytes have become 22 bytes, but address information is definitely there. If the information is sent, as usual, the information will spread across to every system. It goes as usual. It goes to every machine in the world. But one beautiful thing or one advantage is once all the system's physical layers have received that information, they will give that information to layer 2. Now, every computer's layer 2 will be able to read header part. How much is the header part? How much is the header part? 2 bytes. What is there in the 2 bytes? 1 byte is source, 1 byte is destination. Once they read the addresses, the receiving computers layer 2 reads the addresses. What do? First thing they will concentrate is to address. Okay, if the to address is not pointing to their own address, they will tell that, hey, this is not our address. Because we are in this kind of a global sending, we have received it. We see, what do we need to do? Because the to address is not pointing to my address. What I have to do? I have to simply throw that into dustbin. I will just ignore it. I will say I don't care. Okay, I will throw it into dustbin because this data is not for me. I should not remove the headers and should not send the data to which layers? Processing layers. I should not send. Why? Because this is not for me. I am not supposed to receive it because I have received it. I am understanding that it is not for me. I will throw it. How many guys will receive it and process it? Only one guy. Who is that one guy? The guy whose address is matching. You are understanding it? Are you visualizing the whole thing? Okay. One additional layer is adding the headers on the sending side. One additional layer in the receiving side is reading that addresses and finding whether the data is for him or not. That's what I am explaining you. Now, instead of one delivery layer, how many delivery layers are there? 2 delivery layers. What is that additional delivery layer is doing? Adding addresses on the sending side, removing the addresses on the receiving side. But will it work out for us as a solution? Worldwide solution. Let us think about it. Now the biggest problem is How many millions of computers will be there in the world? Okay, now still the data is going everywhere, right? But we will try to act smart and we will do one thing. We will employ some devices here which are containing two layers. How many layers we are actually having for delivery right now? How many layers we are having for delivery? Only two layers. So we will include two layers, two layer devices everywhere. Okay, what these two layer devices will do? They are smart enough. When they receive the information from here, they will read the header part themselves because they are having layer 2 capability now. They will also will be able to read the header. They will be able to read the header. Once they read the header, what do? They will understand there is a to address, there is a from address. If you can give some intelligence to these units in the middle, tell them that so and so address is available at so and so place. What do they do is, instead of blindly sending everywhere, this guy won't send it to this guy now. This guy only will send it to this fellow. This guy will only send it to this fellow. This guy will only send it to this fellow. It won't be sent in this direction. This won't be sent in this direction. It won't be sent in this direction. It will be sent only in a particular desired direction. Why? Why they are doing that? Because we are giving intelligence to these middle devices with addressing and where they are available. We are giving some intelligence to these devices. We are telling these devices that so and so address is available at so and so place. So and so address is available at so and so place. We are giving that intelligence to these devices. Okay. Now it won't go anywhere, everywhere. What will happen now? Things will happen smartly now. What is going to happen? If the data is originated by this guy with from address and to address, it will definitely come to this device. But I am very much confident that this device will not spread that information everywhere. Instead of that, he will be spreading the information only in one direction where he believes the address is present. Okay, address is present in one particular direction. He will only forward in that particular direction. You see, now by attaching the address, you are making the receiving computers realize that whether the data is for them or not. First thing. Second, by including the components in the middle which can read these addresses, by including layer 2 in these components, we can make these components also. What is this? We can make these components also understand where to forward this traffic, where to forward this packet based on the addressing information. But please remember this, guys. The components definitely must have the intelligence about what, which address is where. They need to know that. How that is achieved, that is a different story. That we will go to that later. Right now we are just imagining, just to understand our layer concept, that the middle components are having that intelligence. Intelligence about what? Intelligence about which address is available where. Are we clear? Okay. But now this is the advantages we have achieved by introducing second layer, layer 2. But we see the disadvantages also. Okay. Now, what these middle components will have to do, they have to note down individual address, one address where it is available, individual address where it is available, individual address where it is available, individual address where it is available. They need to have a big list. How many individual addresses will be there in the world? Crores of computers, lakhs of computers, millions of computers, millions of addresses. You see? Can we make all the devices store millions of addresses and note down information about which address is available where? If the middle devices are not there, what is the problem we are facing? The information is spreading everywhere. So we definitely need to have middle devices. If middle devices are there, they are reading the header header part, they are reading the addresses part and forwarding the data intelligently, but the middle devices are facing an issue. What is the problem they are facing? How many addresses they will store in their memory? Okay, how many address related information they will store? How many millions of address informations they will store? That's a big trouble. You see? Now we have to be smart. We have to be smart about what. So, is this giving us a solution? Two layers is giving a solution or not? No. When there is an individual address, if you store the individual addresses in the devices, too many addresses to be stored in the devices will be dead if that many addresses are stored. So it is not giving us any kind of a help at all. Okay, you see? So what they have done? They have decided that no man, if you have to build a worldwide network means we cannot store individual addresses into the middle components. We cannot do that. What do they have decided? You cannot store individual addresses into the middle devices. You cannot, because lakhs and lakhs of individual addresses are there. We cannot store them. So what did they decide? They have decided against this particular approach, gone for a different approach. What is it? What is this different approach? They have told that instead of individual addressing, we use a group address for this group. We use another group address for this. We use one group address for this. One group of computers will have a group address instead of individual address. You see? That group related address, every group will have a group address. Those group related information will be stored by the middle devices. Okay, middle devices won't be storing individual address details. They will be only storing information about groups of devices. It's called as group addresses now. This way is relatively easy. Why? You can group thousands of computers together. You can give a group address to it. Okay, now worldwide number of groups available are less right now. You see, each group has got an address. Now the middle components relatively need to note down what? Only a few addresses, not thousands and lakhs of addresses. Addresses will definitely come down because a big group of computers is having one group address instead of using individual address. Are you realizing it? Are you understanding the trouble and how we are solving it? We are having thousands and lakhs of computers. To solve that, what they have done, these many individual addresses cannot be stored in the middle devices. Now they have decided to use group addresses instead of using individual addresses in the middle devices. Okay, this will solve the problem to a good extent, but this causes one more issue. What is that? I'll explain. Once we have the group addresses, now if this guy is going to send any data by attaching two addresses, he will send it to this middle component. Middle component will understand, oh, the two address is pointing to a particular group address. So what do? I will have to forward it towards that particular group. I will forward it towards this guy. I will forward it towards that group. No issues. But there is one trouble. Once it reaches, once this data reaches this dead end unit here, what happens? It's a grouped address, right? But you have to send the traffic to a individual computer. What happens now? If it is just a group address, it goes everywhere. Now all the computers in that group will receive it. They need to now find out whether the data is for themselves or not. You see? That means if a group containing 1,000 computers, the traffic must be sent to all the 1,000 computers. Now every individual computer have to find out whether the data is for them or not for them, because they all belong to one group. Now the data is received at the destination with the help of the group address, not individual address. It's coming on group address. You see? So what they have done? They have said that, so having either individual address or group address, none of them are solving the issue. So what is going to solve the issue? Having both group address as well as individual address. Okay. So basically what system they have brought in is two-level addressing they have brought in. What is the meaning of two-level addressing? How many layers we are going to have? Addressing layers. Physical layer is only for delivery. How many addressing layers we are going to have? Two addressing layers. What are those? One address is a global address. One address is a local address. It is like two levels of addresses they have brought in. One global address, one local address. What is the help of the two addresses? Global address will help you to reach from one group to another group wherever those groups are. With the help of the middle devices, you can reach from one group to other group. But once you reach a group, once you reach a inviting point of that group or entrance of that group, from there onwards, what do we need to use? Not group address. What do we need to go to? Local address, individual address. You see? So they've said that because we are having lakhs and lakhs of computers, having a single address will never solve the problem for us. We need to maintain two levels of addresses. One is a global address, one is a local address. If you don't understand it in computer mechanism, I will explain it in general human mechanism, you will get it. You are writing a letter to one of your friends somewhere by writing a to address on that. The post department who receives your letter will only worry about how to reach that other post office where your friend lives. These post office guys don't care about what is the house number. What is the house number of your friend? They only care about how to reach that other post office. Basically, they read that, the complete address. In that, what part they will ignore? Individual name, house number, colony. They will ignore all that. They will only worry about how to make this letter reach that dead end post office. That's all. Okay. Once it reaches the post office, what post that your friend's post office people will do? Then they will care about who is that person, what is his house number, in which street he lives. They will care about it and they will make the letter reach the destination to that specific house, to that particular specific person. You see, two levels here. Okay. One is the post office address. The other one is the individual address in that particular post office area. Okay, you have two levels of addressing. The same common sense of postal addressing, they have put it into computers as well. Two levels of addressing. Got it? How this works out? I will explain you that. Processed data. Processed data will come to what? Definitely. Processed data is coming from the higher layer to lower layer, right? For what? Delivery. How many layers we have for delivery? 3. Right now these 3 things are together is taking care of delivery. What the first guy will do once he receives the processed data? He is going to attach some addresses. Which addresses he will attach, guys? Which addresses he will attach? The global address. not the local address. At layer 3, global addresses will be attached. So source global address, destination global address, he will attach. Two addresses will attach to this processed data, whatever the processed data it is. For that, it is going to attach two addresses. Okay. Now what happens? Second level. Tell me, what should happen? Hmm. With the help of this destination global address, your layer 3, this is layer 3 right now, can come to a conclusion about whether the source global address, destination global address belongs to same group or not. They can come to a conclusion. Whether they belong to same group or not same group, they can come to it. Because based on the address matching, if the addresses are perfectly matching, then they will come to a conclusion that both the guys belongs to same group. If they are having perfect mapping, okay, about the addressing, okay. You are writing a letter, you are in a village, you are writing a letter to person who is present in the same village. What postman will do? He will not send it to some other post office. Once he receives the letter, what is he going to do? Deliver it locally himself. He will go and deliver it, because it's a local letter basically. So based on these addresses, what the layer 3 will come to a conclusion. He will come to a conclusion whether this data can be delivered locally or not locally. If it is can be delivered locally, what he will do? These two systems are present in the same group. What happens if the systems are present in the same group? Tell me. This guy is going to put this whole thing inside here. At layer 2, again additional headers will be attached. Additional address will be attached. What is this? Local address 1, comma, local address 2. Why? Because both guys are present in locally itself. Local addresses will be attached and it will be delivered locally within that machine. Okay. What does physical layer do? Physical layer might deliver this whole thing to all the local units. It will deliver. What is the meaning of local units? If we go back to the figure, if you go back to the figure, it will be, if this is delivered with the physical layer, he will distribute it to everybody. He will send it to everyone. You see? But what do? They will try to first match local address. Who? All the guys. Okay. Now, definitely this address matches with one guy's address or not. This local address match with one guy's address. As soon as it is matching with one guy's address, that guy will tell that this is my information because this is matching with my local address. I need to receive it and see what is there inside, because it is matching with my what address? Local address, not global address, local address. The guys who are verifying it and finding out that it is not matching with the local address, what do? They will all throw it. It's right now, it is dependent on the local address or global address. First local address will be verified by every computer whether it is matching with my local address or not. If it is not matching, they will throw it. Okay, because local address is important here in that particular location. Everybody will throw it whose local address is not matching. They say, I don't care what is there inside. Okay, I will only care if my local address is matching, otherwise I don't care about it. But see the twist. If the same thing is to applicable for differently now, process data, source global address, destination global address, process data is packed by layer 3. But if the layer 3 understood that this destination global address doesn't belong to same group, it doesn't belong to same group, what is he going to do then? Tell me. If you tell me this, you are understanding it correctly. Easy peasy now. If it is same group, he is attaching local address 1, local address 2 and sending it. But if this destination global address belongs to a different group, what do we need to do? What you are supposed to do?
It has to send to another group,
Layer 3 will come to a
another global
conclusion
group.
that because this destination guy doesn't belong to same local group, he belongs to a different group. I cannot find out that different group's local address. I cannot attach the local address there because local address is available only locally within that machine, within that group itself. But this guy is what? Outside the group. If the guy is outside the group, what I have to do? I cannot send it myself. What I am going to do is does the intelligent job here. He is going to put his address as the local address, source address. Local address 2 is going to keep local address of the device that is going to take care of this delivery. He will put that device guy's address as the local address. That means if the information comes from here to here, whose address will be kept by this computer in the local address? This device that is there in the middle, right? That device also has got a local address. That device local address will be kept in the destination. Why? Because our L3 guy have come to a conclusion that this data doesn't belong to the same group. I cannot deal with it. Only this device can deal with it. So I am forwarding it to whom? The device, by using the device local address. Okay. It is that local address of the device. So what happens now? When this is distributed to all the computers are going to throw it away because it is not matching with their local address. Whose local address it is matching with? It is matching with this particular device local address. What this device will do? Hey, this is matching with my local address. I need to open it and see what is there inside. He will find out that inside this, what is present. Inside this, there is this frame, this is the data present. There are two global addresses. I will read the global addresses depending on what is the destination global address. I will decide to forward it further. Okay, so he keeps forwarding it further based on this global address that is present. That means local address is only for local delivery. The global address will help him to deliver to the destination, will help him to forward it to the next level. I will take general examples so that you will understand. In a company, 5,000 employees are there. Every employee will write some letters. Now all these letters need to be posted into a post dabba. Internal courier boys will be there. What do? They will take all the letters which are generated by all the employees. They will go and put it into post dabba. What these guys will be doing, or the reverse case you take. Postman will come to your office entrance, will deliver the letters to your office entrance. What internal courier boys will do? They will read the letters and they read the cubicle numbers. They will deliver it to the employees based on the cubicle numbers. You see, internal delivery only they care about. But how the letter reached your office, front office, here with the help of the global address. What is your global address? City name, your company name. Okay, so based on that, the letter has reached. That is global address. Okay, because global address is not matching, this guy took a conscious decision that I cannot find out the local address of the remote guy somewhere here. That guy's local address I cannot find out. So what do? I will simply forward by attaching this guy's global address. I will forward it to this device. Let the device take care. He is going to do the forwarding. You see, two levels of addressing right now, global, local. But with the help of the global address, once this data received at this particular destination, what happens? This guy, once it reaches this guy, what happens? This guy is going to use local address of this machine because this guy and this guy both are local. Once he uses that local address, what is going to happen? If it is distributed to all the computers, everybody will throw it. Okay, only which guy will process it? Only this guy will process it because it is matching with his local address. Now you try to observe the thing it is happening, guys. Information is not getting distributed from every computer to every computer. What is happening? Information is only getting distributed wherever it is required. Based on the, for example, we are attaching two group addresses. It will go from this group to this group individually. It will never reach any other group. It will not go to this group, this group, this group. Never it goes to any other group. Okay, because the group address is pointing to this particular group. It reaches there. Even once it reaches that group, it might not go to every computer because there is again a second level address, what is called as local address. With the help of local address, we will be able to reach individual system within that. You see, two levels right now. One is a global address, one is a local address. To reach a group, we are using global address. Once we reach a group, we are reaching the individual device with the help of local address. Okay. Here, for example, a company having 5,000 employees have got 1,000 letters by using what address? Global address of the company. What is that global address of the company? Company name, company existing street, city, which state? That is global address. Based on that, all 1,000 letters have reached the company's entrance. Now the 1,000 letters must be distributed to individual employees. How that will be done? Employee names, employee cubicle numbers. That is local address. Who will read that local address? The local delivery boys who are working in your company, they will read that cubicle addresses and they will deliver the letters to the individual cubicles. You see? Two levels we have here. Got it? So now are you getting a sense about why we are having three layers right now? Physical layer is not doing much other than transmitting into the cable. Okay, but data link and network are doing what? Adding two types of addresses. And one more beautiful thing I'll explain you here. We can keep a two-level device here. Two-level device here. We can keep a three-level device here. Why is that? Because this guy is dealing with multiple groups, right? This guy is within the group. So this two-level device need to work with which addresses? Only local addresses. If one data comes with a particular local address, this guy knows already which local address is where. He will not blindly send it everywhere. Instead of that, what does he do? He will apply the intelligent and he will send only to one guy. Very easy. Based on that, he will send it. Based on what address? Local address. But when all these local devices are connected here at a, each guy will be taking care of their own local mechanisms, but all these guys are connected at a central point. What is happening at this central point? How many layers we are having at this central point? 3. Why? Because this guy not only need to be worried about local addresses, he need to be worried about what? Global addresses, because he is connecting multiple groups. Okay, you need to understand the data is going from which group to which group. You need to understand that. You need to open and see what is the global address. You not only worry about the local address, you need to worry about the global address. You see, if he finds, if there is one information arrived here, if he finds out that that destination is not this group, then he will not be forwarding in this direction and in this direction. He will be forwarding in this direction because it has to go somewhere else. You need to read the global address. So the devices can be working at two levels which are dealing with local addresses. The devices can be working at three levels which will be working at global level, which will be working at group level. Are you realizing this? Okay. So we have to understand about what out of these layers, which layers will be present where, especially when it comes to delivery part. We study that section first. Repeater. What is a repeater and how many layers repeaters will contain? Come on, how many layers repeaters will contain? How many layers do you see there? Only one layer. What is it layer? Physical. What is the meaning of a repeater? What does it do? It only enhances the signal strength. Nothing else it will do. From one link, the data will come. It will send it on the other link. It won't read any addresses and all that. Its only job is to enhance the signal strength so that the signal can travel further distance. If the distance between the two units is very high, in the middle we keep a repeater so that the signal not die. Okay, you understood what is the job of the repeater? It never reads the addresses. Its only job is to do what? Enhance the signal strength and transmit it once again. Received weak signal, enhanced the signal, forwarded it to the other side. Which level device? Layer 1 device, only physical device. Never reads addresses. It never cares about addresses. Are you understanding that? Okay, good, great. Switch, which is nothing but a local device. Switch is a local device which work in a group. Nothing. Normally, the technical name that we use for group in IP world is called as network. One network. Within one network, we have a switch to connect individual devices. How many layers will be there inside a switch? How many layers will be there? You see, two layers. Physical data link. Why? It receives the traffic in incoming link. Once it receives the traffic, it will read what addresses? Local addresses, not the global addresses. It will be having data link layer, nothing but data link layer is attaching what kind of addresses? Local addresses it is attaching. So switch is reading local addresses, and based on which local address is there in the destination, he is going to forward it by using a outgoing link. Normally the switches that we use in our computer networks will be having typically 8 ports. How many ports, guys? 8. So we have a switch, one port, second, third, fourth. Actually it will not look like this, but I'm just drawing like that. How many ports? 8 ports. If data arrived in one port, what this guy is going to do? Read what part? Read the address. You see? Read which address? Local address. It will read. And after reading the local address, what decision he will make? Hey, many computers are connected to me on each port. One computer is connected. What do I need to do? Based on the local address, I already having the logic. What should I do? I should not blindly send it everywhere. Instead of blindly sending it everywhere, I should be sending only on this particular link. I have received on this link, I am sending on this link. Why? Because I know this. I know that this particular local address that is present in this header that is pointing towards this particular computer. So I have to send it only to this computer. I should not send it in this direction, in this. No, I won't send it. I am intelligent. I will forward it only on one link, one input link, one output link. I am sending it out. You see how he is making the decision based on what? Based on the local address attached in your header. Now you are understanding the headers, guys. Headers are carrying what information? Headers are carrying your addresses information. Who is reading that addresses? Data link layer. which is present in which device? Switch. All right. Now, great. So switches will contain how many layers? Two layers. Okay. But physical links are many. Many physical links. Many incoming links, many outgoing links. If the traffic arrives from one incoming link, it goes out of another outgoing link. It can be many links there. But in the middle we have a reading layer. What is that reading layer? Reading what? Reading address. Router's view. How many layers router will contain? Tell me how many layers router is containing now? 3 layers. Why guys? Router is what? Dealing with networks. Nothing but groups in our previous example explanation. One network to another network. Okay, what does he do? He received data on the physical link, received at the data link layer level, and he checks whether the address is his address or not. As soon as the local address is his address, he will open it and see what is there inside. Once he trying to read it, what he is trying to read? He is trying to read that global address information, which is nothing but in IP communications, it will try to read what is the IP address. Okay, in IP communications, at data link layer level, we have the local addresses called as MAC addresses. What addresses? MAC. And your global addresses are called as IP addresses we use. So your network layer will read what information? IP address information present inside your data. Okay, what is he going to do after reading the global address, after reading the destination IP address? Your router may be connected to many routers. What your router will do, based on the reading the IP address, he says that, oh, this IP address belongs to so and so group. What do I have to do? Even though I am connected to 3 routers, I know that I have to forward it on second router only, because this group is available and it is connected to second router. I know that. I have that intelligence. Somehow I got that information. I have that knowledge. So what do? I forward it only towards a particular direction. I will forward it only to a particular router, to the next router. Based on what? Based on this global address, which is called as a IP address. Based on that, I will forward it in a particular direction. You see? So he will send the data out to the next guy by again packing it and sending it out. Okay, that means you very simple. Where the switches will be there? Within the network, switches will be present. Where the routers will be there? Between the networks. Okay, what is it? Between the networks. Switches will read local MAC addresses, deliver the data only within that network. But when the data need to be delivered from one network to another network, who will come into play? Router. The data will be forwarded to router. Router will read the network level address. That is IP address is called, that is why it is called as network level address. Router will read the network level address, decides that this IP address belongs to which network, nothing but which group. Based on that, he will intelligently forward it towards that group. Once it reaches that group, again, local address will be used to make it forwarded to the destination, to your destination computer within that group. See, within the group, always what address will be used? Local address. But one network to another network we will be using global address, which is your IP address. So your IP addresses are global addresses. They are, you see, global addresses. There is some kind of a logic in global addressing, but data link addresses called as MAC addresses are local addresses, which can be random addresses. There is no pattern for them. Random. Some random MAC addresses, because Within a network, small number of computers will be there. A switch can remember all those random addresses and where they are available. Not a big deal, because within a network, very small number of systems will be present. Okay, but global addresses need to have some pattern. What is the meaning of pattern? There is a IP address pattern: 192.168.1.1, 15.8.8.8. So each pattern address is available where? Okay, there is some logic to it. If it is 15 dot address, it may go to California. If it is 18 dot address, it may go to South Africa, because your routers in the middle know that this particular series addresses are available in this particular location. There is some logic. They are not randomly placed. They are not random addresses. They are logical addresses. They are having some kind of intelligence in their pattern. You see, based on that pattern, routers can detect where these addresses are physically present. Are you understanding it? So there is some logic in those addresses. They are not some random addresses. For example, there are 10 computers in your network. You cannot give some random IP addresses to them. No, not allowed. You have to give some kind of a patterned address to each one. Pattern should match. You see, worldwide routers know that this particular pattern address is available in Hyderabad, Amirpet. They will try to reach this place based on that pattern they find in the address, IP address. See, but local address doesn't need to have any kind of a pattern. They can be random. No problem at all. Because even though they are random, we don't care, because the number of devices in a network are very small. It's only for local delivery. No pattern required. Are you getting it? So all the layers are present in all the components now. Does all the layers present in all the components? No. In the repeater, how many layers are present? Only 2 layers. In your switch, how many layers are present? Sorry, repeater, only 1 layer is present, physical. Your switch containing 2 layers. Routers are containing 3 layers, depending on what they are supposed to do. What is their primary role? Where they are helping in the delivery process, depending on that. The final twist in the tail is this. You remember the groups? This is application, this is processing. Now application and processing will be present only in client and server. They are not present anywhere in the middle components, delivery components. Delivery components can maximum have how many layers? 3. That too depending on what is their role. If they are just enhancing the signal strength, they need to have only 1 layer. If that component is delivering the data within a local network, it need to have 2 layers. If the component is delivering the data from one network to another network, it need to read the global address. It need to have how many layers? 3 layers. Are you understanding the delivery layers right now? Have you got the picture about it? So client and server will contain all the layers, all 7 layers. Processing will be done where? Where your data, the data is generated in the client. Data is processed by whom? Client, to be delivered, to be ready for delivery. So it is like, with the help of all these processing layer units, you will make the data ready for delivery. Once the data is ready for delivery, after all the processing is done by these processing layers, we'll just give it to delivery layers. We believe that delivery layers can deliver the data even if the computer is present in the local network, or even if the computer is present in a remote network somewhere. We believe that it will be delivered, because with the help of what addressing? Global addressing and local addressing. By using these 2 levels of addressing, these 3 layers will deliver it to destination without any trouble. Okay. Now I go back to the slide that we came. Listen to this carefully. First time what we have discussed, what we understood. When we send the data to physical layer, it will go everywhere, right? Now you see what is happening. Assume that layer 2 device is present here. What happens now? If the traffic comes in here, what is he going to do? He will only send it to one link, not all links. There is intelligence or not? Because by reading the local address, he is sending it on only one link. It's not blind forwarding everywhere. It is intelligent forwarding on one particular link that is achieved by your layer 2 device within that network. But if the data arrived here, router received it. Assume that router received it. Assume that we are not using any layer 2 device here. The data entered into this mix point. It is going everywhere. Assume blindly, because I have not inserted a layer 2 device there. I don't want to put that. The data reached everywhere. What happens then? It reaches the layer 3 device. If layer 3 device verifies whether the address is his address or not in the layer 2, if it is not his address, he is not going to read the layer 3 packet. What is he going to do? Throw it. That means he is not going to forward it on this link, not on this link, not on this link. The data is dead here itself. He understands that, oh, I have received this because there is no layer 2 guy present here. Because of that reason, I received it to me. What do I need to do? I should not blindly forward it. I should simply throw it because the address is not my address. I should not forward it. So you are never blindly forwarding the traffic. You are forwarding the traffic on the basis of your need, based on the addressing concepts. You see, now the traffic never goes from any system to all the systems. It never goes. It intelligently travels. It intelligently travels depending on the device's intelligence in the middle. You see, now you understood why the layers are introduced. Layers are introduced for the purpose of intelligent forwarding instead of forwarding it blindly from every node to every node. Okay, within a local network, switch will do intelligent forwarding with the help of local address. From between the networks, router will do intelligent forwarding with the help of global address, which is IP address. All right. So now final slide for us for today. You understood these layers part? Now you see. Now we am considering one computer, another computer, one switch, one router, another switch, another computer. It is like this. One network, another network. Between the networks, what we have? Router, layer 3 device. Switch is only working within that network. Now how this protocol architecture will look like? Switch, computer will contain all the layers. Switch, only 2 layers. Router, 3 layers. Switch, 2 layers. Computer, all the layers. Now how the information travels? One arrow starts traveling now. Observe that. What is the meaning? Data generated, processed, sent to network, added global addresses, added local addresses. Both we need to add. Global address we need to add, local addresses we need to add. Physical arrived, sent to switch. Switch read the local address. Based on the local address, it decided to forward it towards router. router on the router's physical link. It reached router. Router verified his local address in the data link layer level, and he has sent it to network level where he is reading what? Global address. And then he decide to forward it on the next network after reading the global address. He added the local addresses once again and sent it to physical. Physical sent it to this switch. It goes to this switch. What switch does? Switch reads uh, local addresses, and then he forwards that. Because the local address is this computer, I will forward it only through that. This switch may be connected to many systems. He will not forward to all the systems. He will forward only to this system. Why? Because the address that is present is matching with this particular system's local address. So switch will only forward it to that guy's local address. Okay, he will forward it and he will reach it here. Once it reaches here, this guy says, okay, there is some data that need to be processed. What is my duty? I will deliver it to these processing layers. I will give it to above layers. They will do the reverse processing, deliver the data to application. Now, but what we have not studied, what part we have not studied? We haven't studied how these addresses will be known, how the local addresses will be known, how the global addresses will be known, how it will be intelligently forwarded, how these components will work intelligently. That part we did not study. Only part I have introduced is there are two levels of addressing. We use global level addressing and local level addressing. One is working within the network, one works between the networks, so that we can construct a worldwide intelligent networks together. That's all we have studied. Okay. The internal parts of it we will again study there. Right. Now my part is to explain. Uh, uh, I have to introduce the tools. Yesterday we have seen some two tools. I have to introduce another three tools today. So within the next 1 minute, I will be showing you that. Just hold on, guys. For 1 minute, you won't hear anything. Have come back. So we continue the technical part of it and the protocols and the discussion about that in our continuing session. So I'm supposed to show you. Okay. Uh, there is this test cast which I have showed you yesterday. Okay, so I'm going to show you some sample test case execution in here. You won't understand anything, just for the purpose of showing it. That's all. I'm going to execute a MAC test case in LTE radio protocol called as MAC protocol. We have a lot of protocols in LTE, so this is one of the protocol. Or I can even take some other test case as well instead of this. I can actually open uh, like some MME simulator test case, ACTP64 I am opening. What is it? I will explain you. What is that project and all that. Okay. So if you see this, this is actually a MME test case that is out there. So, and in this I can, so actually there is some test case execution that has happened over there. So basically, like this, you can execute the test cases. Okay, so it it gets executed and it will show it as passed, and these are all the protocol messages that are exchanged. So if you be able to go into the graphical view, you'll be able to see that this is the LTE protocol messages that got executed and that has been exchanged between the components, and this is how we do the test case execution as such. Okay, so the test case will get executed and verdict will be shown as pass or fail. Of course, we need to write the script for it. How to write the script and all that I'll be teaching you at the end. Just I have showed you the execution by using the tool. That's all, nothing else. Okay, so this tool can be used for LTE protocol testing, and the protocols that you see over there are GT S1AP protocol and your GTPC protocol and diameter protocols. You can see over there. So this is the diameter protocol information. Diameter is used in LTE core part and as well as IMS. To do the IMS protocol testing and LTE core protocol testing, we'll use this diameter protocol. So the diameter protocol message, how to construct those protocol messages, how to write the script, how to execute the script, when the test case will pass, when the test case will fail, all that we'll be seeing you. This is yesterday's tool only, whatever the tool that I have introduced yesterday. Only I have showed you that execution can be done, the test cases can be executed on this. All right. Now I'm minimizing that part. In fact, I can close that out. I won't explain anything, guys. I won't explain anything in what happened and what is the test case is about, which we study that at the actual learning time. Okay, we are now ignoring it. If you have any question, Magesh, you can type your question. I got your message. Now I'll be using some other two tools. I'm going to show you three more tools which we are going to use. One is LTE tester, which is used for LTE protocol testing. So I'll also not show anything in here. I will directly connect it and do the execution. That's all. For example, I'll go to a predefined project that is already existing. I'll just execute it and show you. Just to show you the execution. How it is constructed, how this tool will work, how to construct the test case part, all that I will not explain you now. So now I directly go start these components. MME component is started, eNodeB component is started. In the background already the messages will start flowing. So I start capturing the traffic. Okay, so start capturing on any interface, start, and I'm going to put a filter here, apply. Now you will only see LTE related messages exchanged between LTE components for log analysis. So once I start all these components, I'll be starting put some procedures over here. So I'm starting an initial procedure. Number of procedures is 10. 10 mobiles will be connected from 1 to 10. I'm selecting eNodeB UU interface, and it is going to be attached. What is that I'm not explaining you? I'm just executing it. Okay, now you will be able to see the traffic over here. You will be able to see LTE traffic. All these are LTE protocol messages that are flowing. So you will do the log analysis by constructing different cases, and you will do these protocol log analysis like GTP version 2, S1AP, NAS messages. What will be there inside those messages? We'll be studying that part. So you have to construct it and do it. But what is this tool? This tool is actually used for LTE and IMS protocol testing by using tool-based mechanism. No script is needed to be written. Everything is graphical user interface method. You just have to click here or there and construct the test case very easily by using the GUI method itself. Nothing, no need to write even a single line of script. Test cases can be executed without writing a single line of script. So some companies will be using script based methods. They will be using TTCN3 or Python. TTCN3 tool I have showed you previously. So that tool we use in order to write a test case script and execute the test case. This is a tool based method where you will use a tool and you will execute the test case. You never write a single line of script. Okay, some companies will use that method, some companies will use this method. The ratio is somewhere around, project ratio is 70 to 30. 70% of the projects will work on script based methods, 30% of the projects will work on tool based methods. So this is for those remaining 30% of the jobs. We learn both. So this is tool based protocol testing. That's why this tool is used. So this is one tool. Now I'm going to go to show you other tool. So this is one other tool which we use. Again, we need to construct the project and test cases. I will take a already existing project. I'll open the project which is already there. For example, whatever the project that we have constructed for old batches, that we take it. And in this, all the things will be there, which is simulated component we are taking. Okay, whether it is eNodeB or whatever, what is the component that we are testing, MME. So you can actually choose the components. For example, in the simulated components also, if you want to add a PTC, I can add whatever the LTE components I want to add. I can add a P gateway 0. I can choose what interfaces P gateway will be adding. This is all your LTE interfaces. Okay, so I'll be adding these interfaces. Like that, your component can be added there. P gateway component is added. You will build a test suite which contain test messages over here, test templates and test messages. If I edit, this is the LTE protocol message called as S1AP. In that, the protocol information will be there. I will explain you how to construct these things, how to construct these messages, but I'm just showing you the part right now, that's all. So in the value part, if you take eNodeB choice ID is micro eNodeB ID. I'm taking it as 25. I'm just saving it. I can save the template if I want. If I save it as template, it will be saved as a protocol message. That is a protocol message which is converted into binary or hexadecimal format, which is already constructed here by the tool. It is converted into that hexadecimal format by every protocol message need to be converted into binary or not. So this is a binary thing. Okay, this is again graphical, which is the script based method we use. Only TTCN3, that is script based. These two tools are graphical tools. One is a functional tester, other one is a load and performance tester. To test the functional testing, there are Two types of testing again, functional testing, non-functional testing. This tool is for functional testing by using graphical user interface based. Okay, the previous tool that I have showed you, this was what? Non-functional testing tool. Graphical user interface based only, but for non-functional testing teams. Two levels of protocol testing will be available in the companies. Functional testing, non-functional testing. This is non-functional testing tool that is used. I got it? Okay. So you do the execution. Once the test case is ready like that, you will do the execution. You will go to the test case execution part, add the test suite name, and you add the test case into that, test case suite into that, and then add the test case into it. Okay. Once the SUT is ready, you will execute the test case. Right now, SUT is not there for this functional tester. We need to have a SUT. If I didn't prepare the SUT part, if I do that, then we can execute the test case. Right click on this. It's all graphical user interface based method. Understanding that? Right. Another tool we use is 3GPP decoder. These are the tools that you find out in our course content we have sent you. The snapshots of these tools only are kept in your course content. If you want, you can now go back and check the course content. You see the same tools over there. So this is 3GPP decoder tool, which we use for decoding the 3GPP messages, different protocol messages. We require this to understand the protocols in a perfect way. Okay, so it will be helpful for us in some scenarios. 3GPP decoder part. Okay, so this is some other tool. Now we have one more tool which is built, but which will only run in the background. Which is called as HSS. This HSS tool will be having thousands of mobile phones and their databases. It will be holding. Okay, mobile phones and their databases. It will be holding in the background. It is not a front end tool. It is a back end tool. Okay, because of that tool only, these many mobile phones are existing. We can execute the test cases. Okay, that is a backend tool. I can't show you it in the graphical user interface format, but it is working in the background. Okay, now what tools I have showed you so far? Okay, I will go back to our course content in testing part. Yesterday I have showed you GNS3 and Vaishak. Yesterday I have showed you this LVR test case, but I didn't show you the execution. Today I showed you the execution, this part. I've just sample execution I have showed you for this LVR test case tool. 3 tools, yesterday's ones. Today I showed you the execution first thing. Next tool I have showed you is this. Okay, which is the tool for functional testing. The second tool I have showed you. This is the snapshots of that. Okay, this is the one I have showed you, right? How the execution will be done and all that. Now this is the first tool that I have showed you. Okay, where components are created, dragged and dropped, and the components are created. After that, we connect the components, we execute the test scenarios, log file will be generated. This is the first tool I have showed you. Yes, it generated the log files. Actually, we have seen that log file also. It generated thousands of protocol messages. You see, these are all the LTE protocol messages that are generated. Every tool will generate the protocol messages. We'll analyze them later, what the protocols are and all that. Okay, but that's the second tool. Now, the next tool that I have showed you is this 3GPP decoder. This is the one I have showed you already. Another tool is HSS tool, which I have told you that will be running in the background. Right now it is having a graphical user interface model, but we are stopped it in graphical format. It will run in the background. Because of this HSS only, the other dependent tools will work because of that particular part only. For example, which I have showed you, all these UE are possible just because HSS is existing in the background. Okay, so that tool will run in the background, this T-Cloud HSS tool, right? So how many tools are completed so far in the things that are listed in your document? Yesterday 3, today I have showed you 4. 3GPP decoder, this I cannot show, but it is there working in the background. Functional tester, non-functional tester, graphical user interface based, right? Only 2 more tools. That 2 tools I'll show you tomorrow: Quality Center and SVN. Okay, so these are the total tools that we use while you are doing the project execution and project related tasks at T-Cloud. These 2 tools I'll be showing in our next class. Okay, so these are the total tools that we'll be covering. Okay, now questions. Yes, L1 messages are captured on most of the interfaces, but on the radio interface, we have bypassed the L1 layer in our tools. In TTCN3 tool, it will not be bypassed, but in our tool, it will be bypassed. In our tools, L1 layer will be bypassed because simulation is happening within the same machine. All the simulation is happening within the same machine. So L1 will be bypassed there. Quoting. Most of these graphical user interface based tools are developed by T-Cloud. We have developed it just for you to work out on those tools and get some practical exposure. When it comes to these graphical user interface based tools, in the market also tools are available, but thing is, those tools I cannot buy it and keep it for you at T-Cloud Lab. Why? Very expensive. Normally it will cost around 2.5 crores to some 10 crores. Typical cost will be. So that is the reason why nobody will provide the lab except T-Cloud in India, is because of that reason. What we have done, I have employed some software engineers, developed these tools for selling it to the companies. Now those tools are now being useful for you to work out on those tools and get that expertise or exposure to the graphical user interface tool based protocol testing. All these tools, you see T-Cloud name over it. See, that is T-Cloud functional tester. This is LTE tester T-Cloud IT. That is developed by us. These tools are. Even HSS is developed by us. All the protocol stack, everything is developed by us. Complete stacks we have developed for making these tools work. Okay. So you can't get anywhere because of this reason, because we have built it. Okay, you won't get it outside because they won't be able to buy the tools by paying 4 crores for your 30,000 rupees course fee. That's why you don't get these tools. They don't get TTCN3 tool also because nobody will be able to make a tie-up with them because they'll never have any kind of expertise at all. Most of the times the other training institutes will be having external trainers coming and teaching on part-time maximum. They don't care for you, or they don't have any collaborations with any companies. Why we are having testcast tool? I have already told you. We won't buy it. We are getting the testcast tool because of what reason? Because we have collaborated with our expertise. We have collaborated with LVR company. That's why they are giving us this tool, and you are having a chance to work with this tool and execute the test cases because of that. Otherwise, we don't even get it. You won't get it if we don't have that tool. You see, the test cast part. Right. Now, what is the real-time tools in the companies? The real-time tools in the companies and the tools developed by T-Cloud are absolutely same. Only the differences will be graphical user interfaces differences will be there. That's all. What is the meaning of graphical user interface differences? I will explain you. You are opening Mozilla Firefox, you are opening Google Chrome, you are opening, Internet Explorer, you are opening different things. By using all these either Google Chrome or Mozilla Firefox or your Internet Explorer, you can go and browse the web content, right? But the graphical user interface differences will be there or not in this. For example, in here, tab will be present here, home button is present in here. If you go to Chrome, it might be present somewhere else. You see, the options are different, but the purpose is same or not. If you learn one thing, you can easily adapt to the other things. Only GUI differences will be there. There is no other differences. Okay, between the tools that we are having and between the tools that companies are using. When you join in a project, in a real-time project, then they will teach you how their tool works, because you definitely tell them that you have not worked on the tool, you have worked on this tool. They will definitely teach you for 10 days how to work on the tool. So you will be able to easily get a comparison between how this tool is working, how that tool is working, because you already work out on this particular tool. You see, that way. It's like comparison job. Elsewhere, you can't get even that experience also. You won't even get that part. Okay, nothing, zero, absolutely. That's why we tell proudly that nobody will provide you the lab in India because of that reason. Okay, nobody can dare to, or they cannot, even if they want to, they cannot buy the things out. Not possible. Okay, because we have developed it, you have the availability to use it. All right. Magesh, I hope I have answered your question about real-time tools. TTCN3 tool is real-time tool. Which one? LVI testcast is real-time tool. Even our tools are also real-time tools. They will generate the same protocol messages which every other tool in the world will generate. Same LTE protocol messages. LTE protocol messages are the same, but only difference is GUI. Graphical user will be different for that other tools and our tool. That's it. Logic will be same. Okay, good question. This course is for both L2, L3 network protocol testing guys also can do this course. Now only difference is first 20 classes when we are learning OSI, the classes will be same for L2, L3 protocol testing and LTE protocol testing. First 20 days only. After 20 days, the teams will be separated. There will be a L2, L3 protocol testing team who will be learning your routing and switching protocol testing, and your LTE protocol testing who will be learning LTE protocols and how to test LTE protocols. Both courses will take a span of 3 months only, but once we learn the basic OSI part of after first 20 days, teams will be separated for L2, L3 and LTE. The subject that we are going to learn is the same for only first 20 days. You have to understand that. You got it? So there are some L2, L3 protocol testers also who are joining now. They will be separating after 20 days. That way. You got it? I will explain that content also. L2, L3, we studying what protocols? L2, L3 protocols, not LTE protocols. Datacom protocol testing. L2, L3 protocol testing, where this part is common, which we are now started, data communication section. After completing this, module 2 will be different. It is not telecom, it is router protocols, RIP, OSPF, EAGRP, PGP, IPv6 routing, all other protocols like IGMP, multicasting, MPLS, VPNs, GRE, IP security related, L2 protocols, and how to test these L2, L3 protocols. That part will be covered in L2, L3 protocol testing. Course duration is same, but protocols are different depending on whether you are working on routing and switching or whether you are working on LTE protocols. That's it. Companies who recruit you also will be different. If you are going for L2, L3 protocol testing, companies that will recruit you are Cisco, HCL, Global Edge, IP Access, Juniper Networks, okay, T-Link, TP-Link, these kind of routing and switching component manufacturer companies will recruit you to test their products. If you are doing LTE protocol testing, then you will be going into the companies which are manufacturing LTE products, which are like LTE mobile phones, E-node Bs, S gateways, P gateways, all the LTE components. There are a lot of LTE components are there. Those companies will be recruiting you. Or IMS product companies, IMS component product companies will be recruiting you. Okay, in case of you learning LTE protocol testing. So the deviance is protocol testing concepts as such are almost same, but which protocols you are learning, which protocols you are testing is different in this case. Either you are choosing L2, L3 or you are choosing telecom protocol testing, datacom protocol testing. That's the difference. Yes. Yes, it is. We cover that part, Sirisha. Instead of Bugzilla, we cover, yeah. Yeah, if you already know Bugzilla and CVS, you don't need to know SVN and Quality Center. You don't require that. But protocol development part I will explain you tomorrow. Both L2, L3 protocol development and LTE protocol development. I will explain that course details tomorrow. Till today, what we have seen? Till today, we have seen a protocol LTE protocol testing course content and L2, L3 protocol testing course content. I have showed you. Tomorrow, I'll show you the development course content and where the classes will be deviated for that. I will explain that in tomorrow's class, development classes. How you will when you join development, what happens? I will explain that part. Okay. Yeah, 5G module. Um, no, L2 L3 protocol testing will be done by using Python. For L2 L3 protocol testing, Python will be taught, and the scripting will be done by using Python, not by using TTCN3. You don't need to use TTCN3 in L2 L3 because there is no compulsory or mandatory condition that we must learn TTCN3. You can do the L2 L3 protocol testing by using Python. So Python will be used for that directly. But TTCN3 is only compulsory for LTE protocol testers, not for L2, L3 protocol testers. Okay. Yeah. 5G module. Now, the LTE module is only whatever I have taught you. This part is LTE, Advanced LTE, and IMS. Three parts will be covered in the next 3 months course. Which parts? LTE, Advanced LTE, and IMS. 5G module is separate. If you are joining 5G module, you will be paying an additional 10,000 rupees on top of the 30,000 you are paying for this now. That your choice, that is optional. Whether you want to join into it or not, you will be deciding on the go. You can decide at the last moment as well whether you wanted to join into it or not join into it. 5G, but it will be starting only after the LTE, Advanced LTE, and IMS module is completed, either development or testing. Once it is completed, then you will be deciding to join 5G part also or not. Okay, that is an optional part for you. It will take about 25 to 30 days. 1 month it will be taking in. Okay, because it is only a changed part of LTE, this 5G part. It's a migrated and changed part, and some additional concepts are introduced in 5G. We'll be learning only that. That will be enough. Protocols are also deviated very less. We'll be studying the deviations in the protocols. That will be enough. LTE protocols only we use it in 5G as well, but changes are there. We understand those changes. We study those changes that way. Okay. No, Python will not be taught by myself, but Python will be taught by the other trainer. Only Python language part will be taught by the other trainer. But by using Python, how to do the protocol testing, how to write the protocol testing scripts, how to do the protocol development, and how to do the protocol development programs, that part I will be teaching you. But Python as a language will be taught to you by other trainer. Okay, when you learn Python here. Okay, but implementation part I will teach you. The actual protocol implementation part I will teach you in Python. We won't be teaching any programming language. I will talk about programming part tomorrow, the development part tomorrow. That time you can ask that question. Today I have only explained you about two things. Which are those? L2, L3